The hypothesis testing decision matrix can be pretty challenging to wrap your mind around. But we're going to go ahead and just start exploring it. First, with a very straightforward approach of working with a large sample size so that there's very little ability in our sample means. And when a treatment has an effect, having it have a large effect. So if there's not much variability in the sample means and any effect you're looking for is really large, hopefully that makes a treatment really pop out for us. So I'll go ahead and click Draw Samples. And down here, you see our population. So population, this is like if the null hypothesis is correct. If the treatment has absolutely no impact, we expect to see a sample that's fairly similar to our population. So scrolling down, you can see that here's this red dashed line that represents the population mean. And there's a green line in there too, and that's a sample mean. And basically it's saying that we randomly selected 1,000 individuals from the population mean, and we got a sample mean that was right smack dab on top of the population mean. That would be very consistent with the null hypothesis saying like, look, there's nothing going on here. You're just randomly selecting from a population, no treatment. And so in most of these cases, there's a sample mean really close. Now over here for sample 6, take a look at this. This population mean is way out there. And yet, normally, when you have a sample of size 1,000, you just don't get that. And so we chose a sample of size 1,000 because there's a little variability in the sample mean, so the null hypothesis is true. And we chose a large effect size so that there is a treatment that its effect to be really noticeable. And in this case, we could expect that for sample 6, that there was an impact of the treatment there. So I'm going to go and I'm going to choose sample 6. When I was asked which sample is affecting, it says, excellent. You've made one correct decision so far. The answer is sample 6. It had a score of 24.06, and it had been randomly selected by this simulation here to have an additional treatment effect of 4.95 to equal 29.01. Okay, so we'll do this again, but you kind of got the idea that for really large sample sizes, we're not expecting any very much variation there. And if we were to see a large amount of variation, then we would expect that to be due to some treatment. So I'm looking at them here. I'm not seeing anything that's amazing. You know, here's the null hypothesis where the mean should be. Here's the sample mean. It's not particularly amazing. So this time, I'm going to go ahead and say I don't think any of the samples had received the treatment. Because remember, if it did, it'd be a large effect. It says, excellent. You have made 2 correct decisions so far. Okay, so hey, if you have the money to pay for 1,000 participants and what you're studying has a huge effect, a really large effect, you're good to go. This hypothesis testing is going to really work for you. For most researchers, we're working with samples of size 25. And for now, I'll leave effect size as large. So hopefully if you're studying something big, right? So here we go. Now your budget is only to be able to pay for or work with 25 research participants. So I'll go ahead and click Draw Sample. Now here's our population, right? A lot of variability there. The mean is 24, standard deviation is 6, and there's a little bit of a skewness. Now take a look at how spread out the scores are, and in particular, the sample mean is much more spread out than what we saw with samples of size 1,000. And here's the challenging aspect. You look at this and you have to say, normally you don't get 10 of them all at once, but you have to say, is that difference because of just random variation due to random selection? Or is it perhaps because there was a treatment effect? And if it's really big, you might then say, all right, I think that this is not just only random selection, sampling error that got it over here, but I think it's also because a treatment occurred that had a large effect. So we're going to say in this case that sample 10 is the way to go. All right. So go up here, choose 10. And this is excellent. You have made 3 correct decisions so far. And keep in mind, when we're doing this research as real researchers out there, Any one of these studies could be like 6 months to a year. So it takes a long time to get to this point, right? And so the answer is sample 10. It had a mean of 25.52, so it wasn't exactly 24. There was some random variation, plus a treatment effect of 4.92 equals 30.44. So far, we're doing great here. I'm looking at sample 2, and that suspiciously looks like it has a treatment effect. Let's go with that. And I wish that if we kept doing it, we'd always be scoring right. And in this case, we did. But when you do this often enough, sometimes it gets confusing. Like this set of 10 is more confusing. Right? I mean, this difference between what the null hypothesis it should be at 24 and what our sample mean is at 25.52, that's probably just random variation. This could be it. Population mean 24, sample mean 21.72. I'm just going to say that for now, just so we get some variety of responses and outcomes. So we picked, in this case, sample 4. Here we go. And it says, good try. You picked sample 4 with a mean of 21.72, and this is called a type 1 error. Sometimes random selection can lead to a particularly extreme sample mean, having nothing to do with the treatment. The correct answer was none of the samples. Now here, we're getting feedback. We're being told what is the true case. But for the researcher out there would have been like looking at sample 4, done a statistical analysis, and let's say that this difference was strong enough that it was appropriate to reject the null hypothesis. The researcher here would be doing a little dance, a little jig of joy, like, yes, I got to reject the null hypothesis, not knowing, perhaps for several years, that it was a type 1 error. The difference was solely due to random selection. And that makes this a little bit more challenging. Now, let's take the challenge level up a bit more. We'll stay with a sample size of 25, but now we're going to say the effects aren't quite as big. It's a medium-sized effect. So a medium-sized effect, if you're thinking of like a standard deviation, in this case, our standard deviation is 6. Medium-sized effect means that the treatment would add, plus or minus 3. So it could add plus 3 to it, could add like minus 3. It's about half a standard deviation of an impact. So let's go ahead and we'll draw the sample now. And when we look, well, I don't think it's sample 1, right? Pretty close there. Could be sample 2. It went from 24 to 25, but probably not. Sample 3 is looking very suspicious to me as random selection and a treatment effect. Some other good contenders there, but let's go with sample 3. Awesome. We scored on it. We do it again. And these are all looking pretty close to me. So I'm going to say none. Wow, nailing it. So you're welcome to come check out this app and see how good are you at eyeballing a difference between what the null hypothesis says it should be, the dashed red line, and what you actually observed, your sample mean. And you have to decide, that there's some variability just due to random selection, right? We call it sampling error. And you have to decide, is the difference big enough? Sample 3 is looking pretty good there. Sample 1 even better. To decide to reject the null hypothesis. All right, give it a try. I wish you the very best.